Okay, I'm gearing up to undo the electrolytic can, and as you can see down there in the chassis there are two wires running towards it. A red one, I think, although there could be another one involved too. I don't know if you can see it, but there are two fine wires running to one lug here, a gray brownish one and a red one, and on the other lug there's a green one running there. Yeah. So I'm going to unsolder these, and then I'm going to unscrew the big bolt which holds down the capacitor can to the chassis. The capacitor of the Philips BX230U wasn't too difficult, and in fact it was more or less the usual thing. As you can see, it was just you could say the regular kind of aluminum can with at its bottom not too much dirt, so I won't even have too much cleaning work. And well, obviously all these parts you see here were inside, but on top of the whole thing was this connector. Yeah, you see there the two lugs of the capacitors which lead to the exterior lugs here. And there's a sort of a rubber gasket which keeps the whole thing airtight, or watertight, or whatever you want to call it, or chemical tight, and that was on top of this. It functioned, the gasket more or less functions as a sort of suction cup. Yeah, so I really had to put quite a bit of pressure on it, or traction rather, to release it. But once I got one side of its lip out, it went surprisingly easy. Then there was this sort of thing, I don't know what it is. It's not exactly rubber, but it might be a kind of silicone. And this was on top of this. This is obviously the electrolytic itself, and as you can see, it's the by now all familiar, or to you all familiar, electrolyte impregnated paper and aluminum roll. So nothing special here. I'm not going to unroll it. It just will disappear into the garbage can. But what was rather special was this little gizmo. Now it's just a piece of aluminum, and as you can see, if I press on both ends it bends a little bit. And in fact it was inside the can like this. The convex side, so the furthest side of it, outward like this, and squeezed between one side of the can and this spring-like contraption was the electrolyte roll, or the electrolytic roll. Why on earth they would do this, I have no idea. I mean, this is the very first time I see it inside an electrolytic can. So this is peculiar. I guess they did it to keep the roll from moving around inside the can too much. But why on earth they would have done that, I really have no idea. There are no markings on it, so there are no letters or numbers or anything. So it's actually really just a, well, a kind of spring, I suppose. Peculiar. Okay, so, well, that's the electrolytic. On with the rest. Technically speaking, I need also to repair the dial movement mechanism, because the cord which runs around this axis, which moves normally not only the dial needle back and forth, but also moves the tuner capacitor back and forth. Well, the cord is broken, and I also miss one piece, namely this bendable wire guide. So yeah, I am in a bit of a fix with that. So what I'll probably do is I'll go and look for a small piece of plastic tubing which is semi-stiff, through which I can put the wire and then somehow fashion a wire guide like this one, like this bendy spring one, and then I could, technically speaking, repair the dial movement mechanism to its original state. But, well, I'm still a little bit working on it. I think I can fix it, but it's going to be a little bit, well, it's going to demand a little bit of inspiration. Also, I realized last time in one of the previous updates, I made an error. I said that this chassis has a power supply based on solid state rectifiers. Well, no, I was wrong. It's based on a tube rectifier. And the tube rectifier is located here at this corner. Now, this is a transformer-less chassis, which means that it takes its power directly from the mains, and it seems to transform the mains power into two high voltages, being the B plus voltage and then another voltage which is called B plus plus. So I guess the B plus plus voltage is higher than the B plus voltage. The schematic doesn't really mention any voltages, so, well, or maybe I read over it, but it's my opinion that it must be somewhere around 240 volts or something like that. Also, there's one more detail that I want to show you. That is that the tuner capacitor moves a lot back and forth. Yeah, it's mounted on tiny rubber feet. I don't know if you can see this, but down there at the bottom, if I take my pointer, so down there you see one of the feet. Actually, there are two more feet on the other side, but, well, what I meant to say is the tuner capacitor is therefore mounted on rubber feet, and as you can see, there's quite a bit of play on it. Now, I don't know if that's entirely normal, but I guess if it doesn't impede the normal working of the radio, then I don't think it needs urgent replacement or anything like that. And besides, I took a peek, and well, it's not that easy to unmount. So, well, if the radio works fine with the variable capacitor as it is now, then I'm not going to work on it, because the agreement with the owner is that it needs to play, not that I'm going to give the chassis a complete makeover. So yeah, that's one thing. And then the last detail for now is that I repaired the electrolytic, or rather the electrolytic capacitors that were inside I replaced with two 47 microfarad capacitors of the appropriate voltage. Normally they should be 2 times 50 microfarad, but I guess 47 is still within tolerance. I take a tolerance of about 10%. So 10% would be either 45 or 55 microfarads. So 47 microfarads will do. So there you go. I replaced the old capacitor roll with two new electrolytic capacitors, and I'm going to mount the whole can back onto the chassis. I also guided the grounding via a separate wire, because the can is aluminum and you can't solder onto aluminum. So, well, anyway, the wire will be hidden under. Take a look at this. Well, I think you can imagine what I've been doing for, say, the last 3 hours. Yeah, I've been changing or replacing all the capacitors inside the chassis, the Philips BX230U chassis. Now, just to show you why I exactly change all the capacitors, well, take a look at this. I don't know if you can see it, but I think you can. You see the crack running all around the shell of this capacitor? Well, that's exactly the reason why I replace the capacitors. Because you see, they can fail, and when they fail catastrophically. And that, of course, in turn makes the whole radio fail catastrophically. And in fact, this capacitor was buried down deep, really deep, underneath a whole lot of other capacitors, very close to the underside of the top of the chassis. So you could have, put the radio into the mains and switched it on, and you wouldn't have seen this, and then boom, the whole radio explodes or catches fire. So that, at least this, is one of the examples why old capacitors should be replaced. Okay, there are other tiny accidents, sorry about that, tiny accidents that needed replacing, like for example this one. This one got, I don't know, melted, or it fried, or maybe in the factory they spilled solder onto it. Anyway, this capacitor needed replacing too. In fact, most of these capacitors are coated with a kind of black tar. I don't know if it is tar, but it certainly feels and smells and looks like it. You see, or like this capacitor, you see, completely cracked open. So that makes at least 3 capacitors that did mechanically fail. So hang on, one moment. Okay, so, well, I don't want to deny you an overlook, or an overview I should say, of the bottom of the chassis, just to show you what I've been doing these last few hours. I think I worked, I don't know, 3 hours on changing all the capacitors inside the chassis, and there you go. That's the result. As you can see, compared to views of the chassis before I changed the capacitors, well, it opened up a lot of space inside the chassis. I mean, it was really cramped in there with all those caps you see over there. But now it's really airy there, and well, and not only aesthetically has it improved, I would say, but from a heat evacuation point of view, it has improved too. Now there is a lot more space for air circulation, and the parts won't get so hot anymore, which in fact is a good thing, because these radios do get hot once they start running, especially those with no transformer. They are packed with all sorts of power resistors like this one here, and those give really a lot of heat. So heat transfer and heat evacuation from these chassis is really of a prime concern. Oh yeah, by the way, I mounted back the electrolytic you see here, so that's fine too. Well, what I'm going to do now is I'm going to put back all the tubes in their respective sockets. Then I'm going to use some crocodile clamps and hang the speaker back to the audio transformer. And then I thought, well, we might give it a go and try to fire up the radio. Why not? It might be interesting to see. So give me a moment to set it all up, and then we'll see what comes out of the radio. Before I get on with firing up the radio, there was one more thing I wanted to show you, and well, I want to discover it together with all of you. That is that I repaired the masonite back of the radio of the Philips. Now, what I did was I put some wood glue in the part that was broken, and then I clamped it together between blocks of wood, and I put some ordinary plastic bags in between, because I didn't want the masonite back to be stuck to the wooden blocks. So well, let's see how it turned out. I need to there we go. I need to undo the clamp and see what the result is. Well, there you go. Well, okay, not too bad. It will need a little bit of cleaning. I will need to clean off the excess glue, but it looks solid enough. Let's see. Oh yeah. Yep. Okay, there's a little bit of give, but it's okay now. So for all intents and purposes, I think it's alright. The only thing I need to do now is clamp it between two boards in the other direction and try to, well, give it back a more or less flat shape, because as you can see it's slightly curved. But I think with a little patience and a lot of pressure from the clamps, I can give it back its flat shape, more or less. Okay, this isn't brain surgery, so it doesn't matter if it's not entirely flat, but as long as it doesn't keep on breaking, because you see the brake was moving down, was moving down the masonite, you know, it started here and then it broke here, then there, then there, then there, and I was afraid the masonite in the end would break off completely. So that's actually why I repaired it with just normal wood glue. I didn't use anything special, just ordinary wood glue. So yeah, that's it. So let's get back to trying to fire up the chassis and see if there's any sound coming out of it. Let's cross our fingers. Well, I've got the Philips BX230U chassis hooked up to my separation transformer and to my variac. I also hooked up the speaker and it's in the off position right now. So let's try and see whether we can get something out of the radio. So there we go. And I'm going to pull up the voltage to say, oh, I don't know, a quarter maybe. So hang on, let's put it on. Okay, well, let's go. Yeah, there you go. That's about a quarter. Well, I can't see filament glow. So that's not too good. Okay, so let's pull up the voltage a little bit. Nothing. Okay, so nothing is happening. Okay, hang on. I think I forgot something. I'm going to hook up my multimeter to the output of the rectifier just to see whether I'm getting B plus voltage or not. I hooked up my multimeter to the B plus voltage, and obviously there must have been some voltage running to the capacitors, because well, as you can see, and strangely enough, now the voltage is even rising again, even after I switched off the radio. Very peculiar. Alright, so let's see what it does when we hook it up to the mains. Okay, so I switched on the radio, and I'm going to pull up the main voltage to, say, halfway. There we go. Yeah, the B plus voltage is rising. Ooh, and it's rising fast. $500. 600 volts. 800 volts. 1000 volts. That can't be right. Okay, now it's dropping again. This is peculiar. I've never seen this happen in any other radio before. I mean, a voltage peak to 1000 volts. That's really, really peculiar. Well, I don't know if that's normal. But whether that's normal or not, I think it would be best to temporarily shut down the test for now, and I need to do a little bit more checking, because 1000 volts, that's really a bit on the high side. So I don't know if my multimeter is doing a little bit crazy, but in any case, seeing a peak of 1000 volts doesn't inspire me a lot of confidence. So I need to check out a few things. I'll be back with another update.